Hi all of you. Welcome to another lecture of antenna and wave propagation. These are the two topics in module 4 of KTU syllabus in AWP. I am Maria Joseph, Assistant Professor in Electronics and Communication Engineering Department of MPC Pyramid, leading this session. Welcome all of you. The first type of antenna that we are going to discuss is the rhombic antenna. In the last class, we have seen a type of antenna called V antenna. Now, let us look into this type of antenna, which is the rhombic antenna. Actually, rhombic antenna is an extension of V antenna. Let us see. This is an antenna in the shape of a rhombus. The structure shows it has got the shape of a rhombus. Two inverted V antennas can be connected at their open ends to form a diamond or a rhombic antenna. So as the figure shows, we can see that two V antennas are connected at the open ends to form a rhombic antenna. It is terminated in a resistance to reduce reflections. In the V antenna also to reduce reflections we used one resistance at the end RL, or we divided it into two sides like RL by 2, RL by 2. That is how we reduced reflections by using a resistance in the case of V antennas, and here also the same is done. Side of the rhombus, angle between the sides, elevation, termination and height above the earth are chosen to obtain the desired radiation characteristics. So all these features, that is the side of the rhombus, then the angle between the sides, then the elevation and height, all these factors will determine the radiation characteristics. Now, to achieve the single main lobe, beams 2, 3, 6 and 7, like you look 2, 3, 6 and 7 are constructively added to get a unidirectional pattern in the case of a rhombic antenna. The other end is used to feed the antenna. The other end is actually used to feed the antenna. In an inverted V antenna, the inverted V is connected to the ground through a resistance as shown in the figure. Look, an inverted V which is shown by the dashed lines. Okay, that is, an inverted V is connected to the ground through a resistance as shown in the figure. Another features of rhombic antenna. Rhombic antennas are usually preferred over V's for non-resonant and unidirectional pattern applications because they are less difficult to terminate. Okay, I hope you have understood what it is. That is, we preferably use rhombic antennas because of their non-resonant and unidirectional pattern applications. Additional directivity and reduction in side lobes can be obtained by stacking vertically and horizontally a number of rhombic or V antennas to form arrays. That is, we can have arrays of these antennas to get additional directivity and reduction in the side lobes. We know that we don't want so many side lobes. We try to remove the side lobes. Why? Because it will not give a positive output. So we want to reduce the number of side lobes. This can be achieved by making this into an array form. The field radiated by a rhombus can be found by adding fields radiated by its four legs. So the total field radiated by the rhombus can be found by adding the fields in its four legs. We know that we have four legs for the rhombus. For a symmetrical rhombus with equal legs, this can be accomplished using array theory and pattern multiplication. By applying array theory or pattern multiplication, we can find out the field radiated and related things with the antenna. Another type of antenna for discussion today is the horn antenna, one of the simplest and probably the most widely used microwave antenna. This is the most widely used microwave antenna. The horn is widely used as feed element for large radio astronomy, satellite tracking and communication dishes found installed throughout the world. So horn antenna is one of the main or important type of antenna because it has got huge number of applications. Used as a feed or for reflectors and lenses and is a common element for phased arrays. The main point is it serves as a universal standard for calibration. That is, this antenna is used in while studying previous pattern multiplication and similar other things. I have told that we used to keep one antenna as a standard one to find out the gain or the measurements of other antennas. So the one type of antenna which is kept for the universal standard for the calibration of other high gain antennas is the horn antenna. Advantages are its simplicity in construction, ease of excitation, versatility, large gain and very good performance. An electromagnetic horn can take different forms, different structures. I mean, different types of horns are there. It consists of a hollow pipe of different cross sections which has been tapered to a large opening. You will understand it when you see the figure in the next slide. The type, direction and amount of taper, the flare, the opening, can have profound effect on the overall performance of the element as a radiator. In a waveguide, the propagation is restricted by contacting walls and waves will not spread. The propagation is restricted by the walls of the horn antenna. After reaching the mouth, waves spread laterally and the wave fronts become spherical. That is, after reaching this, these are the structures of horn antennas. Look, this will be the mouth of the antenna. Okay, just look at the sentence then. At the mouth of the waveguide, a transition region exists where a change of propagation from the waveguide to free space takes place. There is a transition region where the change of propagation from the waveguide to the free space is taking place. To match the waveguide impedance and free space impedance, the walls of the waveguide are flared out. So it is opened up to match the waveguide impedance and the free space impedance. The flaring provides impedance matching, more directivity and narrow beam width. Horn produces a uniform plane wavefront with a larger aperture in comparison with waveguide. That is, we'll see that. Now, this is a structure of a horn antenna. That is, there are different types of horn antennas. That is, it is an aperture antenna. Different types of horn antennas are listed here. Sectoral horn, that is, two figures are shown. That is, E-plane sectoral horn and H-plane sectoral horn is shown. Then we have a pyramidal horn, conical horn, ridge horn, septum horn, corrugated horn, conical horn. So pyramidal horn antenna is shown here. Conical horn antenna is shown here. At least 4 images you have to study. Different types of horn antennas. Salient features. Horn becomes small if the flare angle is small. If the flare angle is small, then the horn antenna is small antenna. Radiation pattern is highly directive. Wavefront is spherical. Antenna area aperture is small. Directivity is small. Then directivity of a pyramidal horn is more as the flare is in more than one direction. Used as a primary antenna for a paraboloid. Okay. These are the design equations for a horn antenna. Look, theta, the angle theta, 2 tan inverse d by 2l. That is 2 cos inverse of 1 by 1 plus delta. What is delta? Delta is this length as shown in the figure. then L is equal to D square by 8 delta. Half power beam width of optical flared horn is, that is, it is given by phi E and phi H. These are the equations. Then we have the equation for directivity, 75 AP by lambda square. Then we have gain, that is 4.5 A divided by lambda square. Then A is equal to W into H is the area of horn mouth. Then AP is equal to DE into DH. These are the few equations related to horn antenna. The design equations of horn antenna is also required. In all other cases, we need to study only the principle and the operation. But in the case of horn antenna, we also need to study the design equations. So you should learn all these equations for the horn antenna. I think you all have understood what I have told in my lecture. Thank you so much for the patient listening, and bye.